All right, so number 33, we got this projectile, which let's just say it's a soccer ball. Although soccer ball being kicked at 60 meters per second, that's quite a kick. So a ball is kicked at 60 meters per second at an angle of 30 degrees above the horizontal. So this angle in here is 30 degrees. The projectile lands on a hillside 4 seconds later. So the ball goes like this, goes up, and then it comes over here, and then there's this hill, right? Here's this hill over here, and the ball lands on the hill, okay? And we're told the time in the air is 4 seconds, so t equals 4 seconds. And what else? That's pretty much it. That's all we're given. Now, what's the key thing for any projectile motion? Any two-dimensional motion problem, you got to separate your information into x and y, right? Whenever you're using one of the motion equations, it's either going to be used pure x, you're going to be taking x information only and using that in a kinematic, or taking y information only and using that in a kinematic. Never, ever, ever, like the 60 meters per second right here, would you ever plug that 60 meters per second into a motion equation? Never. Why not? Is this 60 meters per second, does it point perfectly x? No. Does it point perfectly y? No. It's x and y. So whenever you have a vector that's x and y, what you have to do is break it into components. So I'm going to do this with red. So we're going to solve for the x component of that 60 and the y component of the 60. All right, so how do we get x and y component? With trig, right? So finding this x component, we're going to be using cosine. I'm not going to show the calculation at this point. So it comes out as 51.96 meters per second. Vy initial comes out as 30 meters per second. Okay. Now, what do we know about the accelerations? The problem doesn't mention it because it assumes we know. As the ball flies through the air, what's the x acceleration? 0. Why is it 0? What's the reason for it? The x velocity remains constant. It's like, so what's our starting, when the ball is first kicked, what's the starting x velocity? 51.96. So if we look at the ball right here, what's the x velocity going to be right here? 51.96. What's the x velocity going to be over here? 51.96. The x velocity stays constant, which is not true in real life. In real life, there's air resistance, but we always assume no air resistance. Okay, now, in the y direction, what's the acceleration? Do we have a vertical acceleration? Yeah, the y velocity changes. What's the explanation for why the y velocity changes? Because what's in the y direction? Gravity. Gravity is our y acceleration, which is negative 9.8. Okay? All right, so I'm going to delete this text so we have room to solve this. Okay, the first question is, oh great, I deleted it. What was the first question? Find, oh I remember. Here, we'll just put it back. The first question is, what is the projectile's velocity at the highest point? So we'll just make note of what the question is asking for. At the very, very highest point, what's the ball's velocity? Now, do we even have to do a calculation for this? We already know the answer. We have the answer to the first question already. What's the velocity of the ball at the highest point? Well, let me ask you this first. What's the y velocity at the highest point? 0. At the very highest point, there is no vertical velocity. The ball is not going up and it's not going down for a split second. Okay? So what is the velocity at the highest point? It's the x velocity, which is what? 51.96, which you could just round that to 52 for your final answer to A. All right, now B. B wants us to solve for the straight line distance from where the projectile was launched to where it hits the hill, hits the target, hits the hill. Okay, so the straight line distance is going to be from here to there, right? We're looking for the straight line distance. How do we do this? Well, what we're going to need to figure out, we're going to need to solve for the x displacement, right? How far does the ball travel in the x direction? And then we're going to need to solve for the y displacement. Once we have x displacement and y displacement, how do we get the straight line distance? Once we have x displacement, y displacement, then we just do what? Pythagorean theorem. Okay? So we got to find the x displacement and the y displacement. Okay, so finding the x displacement. There's only one x equation, right? What's the only x equation for two-dimensional motion? Vx times t. So what was our x velocity? 51.96. And they gave us the time as 4 seconds. All right, so x comes out as 207.84 meters. That's this x right here. 207.84 meters. All right, solving for the y displacement. I would just go y equals 1/2 gt squared plus vy initial t. So y is 1/2 negative 9.8. Time is 4. Vy initial was 30. Time is 4. And then y comes out as positive 41.6. So we now have our y. And now we can solve for the straight line distance. You do Pythagorean theorem and you get 212 meters. The straight line distance is 212 meters.